Technical narration with logic explanation. ATOM framework. Pushback sphere is defined as the central region of maximal compression in the eternal field. It is not an arbitrary naming choice. It represents the origin of torsion pressure and the point from which radial stress propagates outward. The term pushback reflects the fundamental mechanism. When the eternal field is compressed, the center resists further compression, generating a restoring torsion force. Mathematically, the pushback sphere can be modeled as a region of radius, r0, with torsion amplitude, tau score 0, generating a radial pressure field, PR, that decays with radius. PR, sim frac tau 0, r squared, quad r, g r0. This central resistance defines the boundary conditions for torsion propagation in surrounding layers. The onion layers terminology arises because successive shells of the eternal field form radially around the pushback sphere, each with slightly differing torsion amplitudes, tau I, and radii, ri. They are called onion layers to indicate that each layer is an oscillatory extension of the central pushback sphere, not independent. Each layer partially inherits torsion energy from the inner layer, but its dynamics are slightly scaled by radius-dependent factors. Tau I equals tau 0 Fri, quad F Ri plus 1 Fri. The energy difference between adjacent layers quantifies the potential for stabilization of a filament. Delta EI equals frac 1, 2, Ki, tau I minus tau I plus 1 squared 2, where Ki represents the effective torsional stiffness of layer I. This energy gradient is the mathematical reason the structure is called onion-like. Each successive shell carries less energy but remains dynamically linked to the center. Adjacent layers are arranged with alternating chirality, clockwise, counterclockwise, which creates torsional torques along filaments. Gamma I equal 4I equals Ki by tau I plus 1. Gamma I quantifies the torque contributed by layer to a filament threading the layers. Total torque along a filament spanning n layers is gamma arm total equals sum I equals 0 squared n gamma I. The filament propagates only if gamma arm total, gamma min, the minimum torque required to overcome viscoelastic drag of the eternal field. This is why the pushback sphere and onion layers are functionally defined. The inner layer provides the initiating torsion, while each successive layer mediates stability through energy gradients and chirality-induced torque. The number of layers is critical for stability. Define Ci as torsion coupling between layers and Ki as local stiffness. Linear stability requires prod I equals 1, 1, frac Ci Ki, quad right arrow, quad sum I equals 1 Ci Ki, characterism 0. With geometric decay, Ci equals C0 Q Qui, Ki equals K0, the critical shell number is Nc equals or frac 2 N C0 K0. This explains why some layers are necessary. Below Nc, torsion energy dissipates before forming a stable filament. Above Nc, linear instability arises, giving rise to eigenmodes. Linear modes satisfy m.x Kc x equals 0. Anti-symmetric modes, omega squared 0, dominate first, causing neighboring layers to oscillate out of phase. These oscillations provide the mechanism for filament ejection or condensation, dictated by torsion gradients originating at the pushback sphere. Nonlinear cubic saturation further determines amplitude, m has.x plus gout.x plus kc plus beta x3 equals 0 minus beta 0, smooth approach to stable amplitude, x army equals frac ckk beta, condensation into mass. Beta 0, abrupt filament ejection, potential toroidal premass structures. Filament transport occurs in the viscoelastic eternal field. M at x plus gamma dot x, epsilon x plus beta x squared equals f arm medium t. Here, f arm medium t represents compression pulses of the field. Phase coherence between the filament and field pulses determines whether energy attributes to mass formation or dissipates. Finally, a Lagrangian for the coupled system is mathcal L equals sum equals 0 get n nice 1, left frac 1 2 mi dot x squared minus frac 1 2 ki, xi minus I plus 1 squared 2 minus frac beta 4 xi 4, right, sum equals 0 squared n minus 1, xi f arm medium t. Euler-Lagrange equations reproduce the dynamics of torsion propagation, filament stability, and emergent mass. The pushback sphere and onion layers are defined mathematically and conceptually. They are not visual metaphors, but functional constructs representing energy source, gradient, and coupling required for emergent mass.
Don't forget, share, like, and more importantly subscribe to show Signs of Intelligent Life.